Rishabh. And now I would like to call Vishesh Khanna on stage to talk about Demo 1. So let's welcome.
One of the pillars of KDE. So around 4 years ago, KDE 4, 5 years ago, KDE 4 was released. This was a big transition from KDE 3 to KDE 4. And as you guys know, we depend heavily on Qt. So Qt also changed version numbers from version 3 to version 4. And this is a big change on their part, and it is not backward compatible at all. And therefore KDE also took a long time to go from KDE 3 to KDE 4. This is a big transition where we went from stuff that looked slightly like it was made in the late 90s to modern UIs, something like Vista, transparency, all cool effects. So we had a major transition. And one of the big things about this transition was that we decided to split up our applications. Earlier on, when you had an emailing application, all the logic of getting the emails, everything was just in that application. And if somebody else wanted to get emails and show them in a separate way, it was kind of hard. So what we did is that we split up all the core functionality into small components, and we call them the pillars of KDE, that all applications use a central backend. So there's actually a very simple demo we can show sometime, that with a certain framework called Econadi, with a simple framework called Econadi, you can actually create an emailing application within 5 minutes. I am not making this up, this is not my coding speed, general coding speed, 5 minutes, and you can write an entire emailing application. The main reason for this is that KDE provides all the backend code that it provides, how to automatically fetch emails, how to display them in a nice way. All of that is provided by libraries. So we developed a large number of libraries in KDE 4, and then we decided to base applications on top of them. Instead of KDE 3 times, they were just applications which had libraries inbuilt. So this was a big transition, and it took some time. But now we're 5 years down, KDE 4.10, that's the 10th release. Every 6 months we have releases. Shantanu already talked about Plasma. For those of you who, Plasma is our workspace. It's what you see, the taskbar, the wallpaper, everything. Right? So it comes in many form factors. We've already talked about it a lot, so I'm not going to reiterate. Econadi is our framework for personal information management. This includes emails, events, contacts, your contact list, all of those things like in the Windows world Outlook. So we have our own alternative, and it goes by the project name of Econari, and it has many applications under it like Kmail, so that's for emailing people. Contact, that's the K. We have this thing in KDE 3 times that all applications have to start from K. Kind of like how Apple does it. All applications, so they start with I, not applications, but iPad, whatever. So we have that whole K thing. Now at KDE 4 times it's somewhat gone, but there's still remnants of it there. So you have another framework called TIO, which stands for KDE Input Output Subsystem. So this is our abstraction over the file system, and it allows us to do really cool things like it doesn't matter where a file is, you just type in the URL, it will figure out how to fetch it and give it to you. I'll show you some examples of this because TIO integrates with everything else and allows us really cool things. Finally there's NepoMock, which the rest of the talk is devoted to. And there's another one that's called Kate. Now I was telling that KDE has all kinds of applications. We're ranging from music applications to integrated development environments, to text editors, to workspaces, to media centers, to emailing applications, you name it. Therefore, we generally call KDE as the community now, because earlier on we were a desktop environment, K desktop environment. And the K actually stood for cool, I know, KOOL. Yeah, those were the days, 90s. So, nowadays KDE stands for the community, and we can no longer just call it a desktop environment, because we have so many applications going on, we have so many workspaces going on, and from a developer's point of view, we have many libraries going on. So we have libraries for creating archives, we have libraries for fetching email. All of this stuff is built on top of Qt. So we have a lot of important Qt libraries which are useful even if you aren't doing KDE development, but you want to use some libraries that provide some amazing functionality. So KDE provides a lot of these libraries. And for Qt 5, what's happening is that Qt 5 just released this December. What's happening is that a large part of the KDE code base is merging into Qt. So we are literally one of the largest contributors there is because KDE libs is being split up and large parts of it is going into Qt. In the Qt 5.1 release, certain parts of KDE is going in. Alright, so Kate is our framework for creating our own text editor. So it's the backend that's used by Kdevelop, that's our IDE, and simple applications like Kwrite and stuff. So it's just a text editor which allows all the syntax highlighting and everything I showed you in Kdevelop yesterday. Right. So this is the pillars, and this is roughly a broad overview of some of the components in KDE. If you want to know about any one of these components, just talk to us. There's a whole KDE application section, which includes all of these education applications and IRC applications like conversations, loads of applications. KDE is no longer the desktop environment, it's the community. Alright, so let's go on to NepoMock, which is something I spend a lot of time on. The first question obviously is, what is NepoMock? And it's a little hard thing to answer, and it involves a lot of research work and stuff. So I'm just going to give you the most simple explanation and not dive into the actual research of why NepoMock was created and everything. For all intents and purposes, it is a place to store information, and it's used for searching. So Shantanu showed some examples of how he was searching through something and showed all the files. So in KDE, it is used for searching. It searches through your files, it searches through your emails, it searches through everything. So searching is comparatively simple to do. I'm not saying it's a very simple job, I mean Google's made an entire business out of it, but comparatively just doing text-based searching is simple. If any of you have studied natural language processing, anyone? 4 years? Okay. You will study it, it's an interesting subject, but just text-based searching is somewhat simple to do. So you search through the text, you find that word, and you have ways to optimize that. We are a little bit more than that. We believe that we are a structured storage medium. So this is a place where you store data in a structured manner so that it can be queried. Now I'm not going to go into the details of how we actually store it. It's not SQL, it's something else, and there's a lot of history behind it, which if you guys want to know later, come talk to me. If by the end of the talk you still want to know, I can give you a brief overview of it. But right now I'll just tell you, it's just a structured storage place where we store data in a structured manner, and I'll show you examples of that. Great. Please stop me for questions anytime in the middle. Let's not do questions in the end. I'm in these slides right now. Nepomuk is mainly split into three parts. There is some features for extracting data. That means I need to get all the information from my files from loads of other places so that I have information in my database. So a database is only as powerful as the information in it. If it doesn't have any info, what's the point? Right? So one huge part of Nepomuk is filling up the database with stuff that can be used. And another large part is obviously browsing the database. And the third part is visualizing it in creative ways. This is not a simple row and columns database, so you don't have just one way of looking at it. And because this is meant for end users, we aren't talking about programmers. I mean, programmers get really excited about databases and stuff. This is for end users, so we need to show them really creative ways of interacting with the data, visualizing the data. That is really important. And actually, this is one of the areas we're grossly lacking in. So if you're interested in creative ways to show data, like tag clouds is somewhat started in the old 2002 when the whole Web 2.2 thing happened. But it's one of the most innovative ways to show tags and stuff. So if you can think of creative ways, come talk to us. There's a lot of scope for this. Right. So let's get started. Data extraction. Yeah.
Is there a command line for searching the files?
Yeah, there is, but it only gives you the file name. I try not to focus too much on command line tools because you can actually just type the query directly. But this is more for programmers. My main focus and KDE's main focus is end users, practical, normal people who don't know that much technical details and aren't comfortable with the command line. So we try to integrate this in file managers and separate applications for searching. Yeah, but there is a semi-command line I'll show you that. Alright, data extraction. This is one of our biggest jobs and I think we do this really well. So, simplest way to extract data from is obviously files. And this is actually what people think Nepomuk is all about. It's a file indexer. So we go through all your files, or whatever subset you want, you can choose, and we'll extract all the information from it. So from MP3 files, we'll extract who the artist is and what the album is. From text files, we'll extract the plain text data, so you can search through that. Video files don't really have any metadata, but we still manage, so I'll talk more about that later. So we basically just go through all your files and extract all the data. This is a slightly cumbersome implementation on the technical part because each file format has a different way of reading into it. So you need to extract, for example, from a PDF file, you want what's the title of the PDF. So not all PDFs include the metadata, so sometimes you need to go into the first page and try to parse whatever the header is. So each file format has a different way of getting into it, the binary format. So it's a little complicated because we have to support all these different formats. So we generally do this in a plugin. We do this in a plugin-based framework. So you can write plugins for extracting stuff from, let's say, EPUB, like ebook formats, from MP3 formats, and recently, by recently I mean 5 months back or so, we scrapped away our old way of doing it. Name I'm not going to mention anymore since it's not relevant, and we went to our own system. So we support a large number of files now, but we still don't support quite a lot of files. So if you want a very simple task to do in Nepomuk is to see if you can search through that file. Talk to me more about it later, but it's a very simple task. Find a file whose information we can't read, inner information, that means some information that's stored inside the file. If we can't do it, let's write a plugin to extract that information. So you have to parse the binary format of the file, or you have to find a library to do that. It's preferable to find a library because then that library can do the work for you. Alright, so file indexing is a very large part of what we do. Most people just think we're just a file indexer. Great. The second last thing we do is email indexing. Nepomuk is kind of the central structured storage medium of KDE. So we interact with all kinds of applications. So if you're working on Nepomuk, you have to interact with all kinds of people. By people, I mean all kinds of groups of teams. So we even interact with the PIM team, that's Personal Information Management team. So for them, we have to index all their emails, all their events, all their contact information. All of that we take into us and we store it, and so that people can do full text searches on emails. We do a lot more than just searching, but let's just focus on this and I'll show you examples. Instant messaging. we have this framework in KDE which is also used in Chrome, so it's a centrally used thing called Telepathy, which is our abstraction over instant messaging frameworks. KDE, we believe a lot in abstractions. So for all instant messaging frameworks, there's one user interface and there are different backends that are available. So there's a backend for Gtalk, there's a backend for Facebook, there's a backend for Yahoo Talk, if anyone actually uses that. So the backends for all kinds of things, and there's a contact list that's shown and you can chat just like any other application. So this entire contact list is there, and so this information is also fed into Nepomuk. The main reason it's fed into Nepomuk is because we're a structured storage medium. So our main job, or my main job, is to connect all the data together. So I get information from your emails that, okay, there's someone with this email address. And then I get information with this name, and then I get information, there's a contact in your instant messaging list with this name. It's probably the same person, so I should combine them together. That this is one person who has an instant messaging account by this, who has an email account by this. And this is fundamentally the job of Nepomuk, that is connecting all the data together. So even when you're indexing files, if you have a movie, say 8 Mile, in which Eminem was there, and you have a lot of songs by Eminem, so it will connect all of these together that, okay, this is the same person, it's Eminem, who's there in these movies, who's there in this. So when you search for Eminem, it will show you all the relevant information. And you can even do stuff like, suppose you, God forbid, know Eminem, and he's written some books and he's even there in your contact list. It's represented by the same thing. This is Eminem, he has an email ID, you have some books on your system who he's the author of. So the main job is connecting all of this information. And if you know a little bit about data structures, it creates this one big graph of all this information. So there's this one person who's part of all of these things, and it's this really rich place to store data. So yeah, our main job is connecting information. So we get a lot of instant messaging information about all your contact lists, and we know who all you talk to, and at times even know what you're saying. Great. And finally, one of the things I really care about, this is something that we've been doing recently, is something called a web extractor. The web extractor is that in video files, especially, we all have loads of torrent files. This is not being recorded, right?
It is.
Okay, so we all have legal ways of getting movies and torrents, and not torrents, but seasons. And we all have our laptops populated with that. Unfortunately, these files, they don't contain much information about what we're actually watching. There's just the file name and then there's the content. So we probably want some more information about it. So that's where the web extractor comes in, or you can call it web miner, whatever you want. That we look at the file name and then we browse online for that information and we fetch information about it. So I can show you examples of this actually. Here. We have Back to the Future, which is the name, and it has a lot of information about it, like the genre, the actor, aspect ratio. And notice how I said we are bad at visualizing information. This is not a nice way to show information to the user. This just looks like a wall of text, and this is something we should really improve. So if you're keen on having a lot of data and just finding ways to show it, like we have a banner of this, we should probably show the banner somewhere. And this is a lot of usability information, like what's the best way for us to display this information to the user the best possible way. So we have a lot of info, and this is fetched online from, generally this is done from IMDb, but there are legal restrictions in fetching data from IMDb, so we use other sources. There are ways to fetch information about your seasons. There are ways to fetch information about all your seasons, so you watch something popular like Homeland, which is pretty great actually. Can you even see it? Yeah. So it will fetch information, okay, you have season 1 of Homeland, these all episodes are there in season 1. It will even fetch the rough synopsis of the episode. So you have a lot of data in your hands, and this is also, KDE believes a lot in plugins. So this is also done in a plugin-based framework where we have different plugins for different backends. So right now we have one for movies, we have one for seasons, but we could really use one for books. And what I would really like is for contacts. So I have Coldplay, one of my favorite artists, and I'd like more information about Coldplay to be there. So which all band members are there in Coldplay and information like that. So one place where all of this data is actively there is Wikipedia, but part really hard. So there's a project that's come up called Wikidata. You should all check it out. It has a lot of structured information which is easy to parse, but it's in its infancy right now, so we can't use that. Yeah, so web extractors. This is a big area where you're fetching information. One big concern that comes up is privacy. That legally there might be some hassles if somebody knew all the data you have because it's being queried and queries are being sent online. So the service where you're querying for all this information, do you have any information about this season, there might be some conflicts. So privacy is important. So a lot of concern goes into not enabling these features by default and allowing the user to say, yeah, I'm comfortable with you querying online for this information. Privacy is really important in Nepomuc because we contain a lot of your data. You contain all your files, your emails, your conversations. There were plans to even track which application is open when you're talking to which person, but thankfully we didn't go that far. Yeah, we know a lot of information about you. So all this data generally resides on only one system, and we try not to share it. Another way of getting data is tags. This is not an automatic way of getting data. All these previous ways were automatic. This is more of a user way that when you save a file, you generally give it a file name and you give it a directory to save it. You can also give it tags. Like this is related to my college, this is related to work. You can give multiple tags, and by that you can even search by the tags. Actually there are examples later, so it's fine. The next user-centric way, tags and ratings are one of the first features we implemented since this was around 4.2 or something. That was 4 years ago, not long before 1 year before I joined Nepomuc. So ratings are a simple rating on the scale of 1 to 10, and it's visualized by a star, which you'll see. Right. So these are the main ways you fetch data. Any questions? Great. I hope I'm not going too fast. The main reason for fetching all of this data is that we populate our database and that we can do interesting stuff with it. So I'm going to show some of the things we can do with our database. The first is obviously browsing your data. So you saw the information bar and you can have tags on it like heroes, whatever. And you can click on any of this information and you can search or you can browse your files based on that. So let me show some simple examples. Music. And I have this song which has all the information, the title, the performer, the album, and I can click on the album and I'll instantly get all the songs. I can click on the genre and I can get all the songs. There's a lot of them. And I can even click on the track number and get which all songs are track number 1. So you can literally browse your data in any possible way, and we're finally moving away from the traditional hierarchical file system where you have one folder, inside that you have many more folders or a tree-like structure is made. Sometimes you want data to be multiple places and linking them isn't convenient. So this allows you to view your data in loads of different ways. Right. So another way is obviously by tags, which I can again show you. So you can type tags and you have a list of tags you have, and so you have a list of tags. So you can browse your files based on which all tags are there. You can filter tags. I mean, since we're right now just focusing on files, at least the examples I'm showing you, it finally moves away from the traditional way of showing files, and you can browse stuff by even tags and ratings. You can choose which files, and you can even browse files by when they were created. So you have a global timeline, which is March 2001, Tuesday, what files were created. This is really convenient when you're working on projects and stuff. What was I working on yesterday? What files did I modify day before yesterday? What files did I work on yesterday which had this tag or were related to this thing? And because you have all this information, you can even relate stuff in crazy ways that, okay, this is one of my contacts who I'm getting emails from, who is in my messaging list, and he is related to these files because I'm doing a project with him. So you can even filter information by person. So this is a simple artist search, Coldplay, but you can even search by an actual person. So there are many different ways of browsing your data. And finally, there are by queries, so you can actually type a full-fledged query. Let's say perform a Coldplay album this, or perform a Coldplay and some other performers. You can mix all kinds of queries, and NepoMook allows you to let's see. So let's create a simple query. NepoMook search perform. Cool. Right. So this is a very simple result, and NepoMook allows you to even, let's say, create this and save this folder so that later you can put it in your places panel. Like there's a today option, so to show all the files I worked on today. You can plug into your things. You can create a widget for it. Add widget. Let's say. Folder. So you can type and you can have this on your desktop. So you can show all of your files in many different ways, and you can plug it all around. This feature, which allows me to use, I've written a certain way NepoMook parses or displays all the files, and then it can be used all across KDE. So it can be used in a widget, it can be used in your open file dialog. So you're opening a new file, and instead of showing the traditional all your files, it can show you the files you last modified, which makes a lot of sense, especially in some places where you're attaching an attachment in an email. So email, attach, add the attachment, and it instantly shows you the files you last modified. Because that's generally the thing, when you're attaching an email, you just probably created the file or modified it. So it makes a lot of sense. So these kind of simple changes, but they really help the user. And this is not something you can traditionally do on a web browser, because we're directly interacting with the file system and providing an intermediary. Great. So you can create these queries, and you can have folders for all kinds of stuff. Great. Another use for all of this data is applications. So we just don't allow the user to browse files because we have so much data about it. Applications can use this data instead of actually building their own data set. So a popular application like Amarok, instead of actually indexing all the files itself, it will index through your entire music collection. This is a popular thing. You have any music player, it will go through your entire music library and create a database of it. You can already use the pre-existing database. And because we fetch information from many different sources, it will even have more information than your traditional simple database. So a lot of information is shared. Plasma Media Center, which is something Shantanu works on heavily. This uses NepoMook a lot. So all the videos he showed you, they were all in the backend was NepoMook, and it was being used to browse data. And Digicam. So this used to support NepoMook, now it currently doesn't. Digicam is a photo managing application. It helps you manage your photos, and it's actually one of the best applications there is for managing photos. It's won a lot of awards and a lot of stuff. It interacts very well with cameras, and the maintainer is this guy who loves photography, so he actively maintains all kinds of camera models that support it. This is an ideal place for NepoMook to be supported, that you have pictures and you have albums, and NepoMook should know about this stuff. And the great thing about Digicam is that it has facial recognition. So it automatically recognizes who is there on your photos, and this is an ideal place for it to push the data to NepoMook. Hey, I already know about all your people. Okay, this person is there in your email address, this person is here. Where all is he there in your photos? So I can say, here's an email address, show me photos of this guy. And Digicam has all this information, and at one point it used to export all the names as, at least the people in your pictures as tags, but we need proper integration where it's actually sent as a person. And this is actually something I'm looking for. This Google Summer of Code, I'm hoping to find a student to do this. That all the Digicam data is properly exported, and you have a